Now let us discuss about what is energy. Energy is the ability of a body to do work. That means energy can be classified into macroscopic and microscopic forms of energy. And what all comes under macroscopic forms of energy? Macroscopic forms of energy include kinetic energy and potential energy. If it is an open system, you have another form of energy that is called flow work. And microscopic energy means the internal energy of a gas or the medium or the system. Now let us discuss about what is macroscopic forms of energy. So we have seen that this includes kinetic energy and potential energy. So kinetic energy is defined as half mv square, and kinetic energy of a rotating system, this is a rotational kinetic energy, is equal to half I omega square. I is the moment of inertia, omega is the rotational speed. And we have the potential energy. Potential energy is equal to mgz. So these are the macroscopic form of energy. So usually it is used for a closed system. For an open system, we have another macroscopic energy, that is the flow work, which is given by P into specific volume. Now, how will you find out the total energy of the system? So better we call it a closed system. Total energy of a closed system is equal to total internal energy, that is a microscopic form of energy, plus potential energy plus kinetic energy. These are the macroscopic forms of energy. So this is equal to U plus half mv square plus mgz. So this mole is the total energy per unit mass. So if you can divide the whole by mass m, this is equal to small u plus half v square plus g into z. Now let us discuss about internal energy. So what all comes under the internal energy? See, internal energy or microscopic energy includes sensible energy, that means which includes molecular translation. So internal energy is mainly concerned with the energy of the molecules. And what all energy does this molecule possess? It includes the molecular translation. That means the molecules of a system can move. It has got a translation velocity. So there is a kinetic energy associated with this translation velocity. So internal energy includes that energy. And then we have the molecular rotation. That means these molecules rotate around an axis. So it includes this rotational kinetic energy. Then we have the electron spin. That means the electrons of these molecules may spin, and there is an energy associated with that. And you have the molecular vibration. That means the molecules or the atoms of a system may vibrate, and it has got an energy. And then you have the electron translation. That means the electrons will move around the nucleus. So this has got an energy. Electrons possess an energy. And then you have the nuclear spin. That means inside the protons and neutrons may spin. So it has also got an energy associated with it. So sensible energy is consists of these 6 forms of energy. So internal energy is mainly concerned with the energy of the molecules, and these molecules possess 6 different types of energy. That means the molecular translation, molecular rotation, electron spin, molecular vibration, electron translation, and nuclear spin. These all comes under sensible energy. Then this internal energy also includes, we have already discussed the sensible energy, and we have got an energy that is the latent energy. That means energy um, released or gained when it is converted from one phase to another. This is a latent energy. For example, when water evaporates, it absorbs energy, and water vapor condenses to water, it releases energy. So this is the latent energy. So this latent energy is also part of internal energy. Then we have the chemical energy associated with the system. If there is any chemical reactions, energy can be released, or so it poses a chemical energy. So that also comes under the internal energy. Then we have the nuclear energy. Due to nuclear fission or fusion, it poses an energy. So in most cases, this our thermodynamic system, this can be neglected. Nuclear energy, chemical energy is usually not, unless there is a fission or there is a chemical reaction. We do not take this chemical energy and nuclear energy. So internal energy mainly consists of sensible energy. We have seen six different types of sensible energy, and then you have the latent energy, then chemical energy, and nuclear energy. So once again, nuclear internal energy consists of all the microscopic forms of energy, which includes sensible energy, latent energy, chemical energy, and nuclear energy. Now let us see what is the difference between a microscopic kinetic energy and microscopic energy. We have seen that microscopic kinetic energy is the kinetic energy associated with the molecules, and microscopic energy is the kinetic energy of the system. So let us see a dam inside in which there is water molecules. There is a paddle wheel fixed inside the dam, and also the paddle wheel fixed here. So you can see that the water molecules at the bottom, it moves at a same velocity, it moves in the same direction, and these water molecules can rotate this paddle wheel. So the paddle wheel rotates, but inside this dam, this paddle wheel does not rotate. Why? Because these molecules also, the water molecules also possess an energy, which is the microscopic forms of energy or the internal energy. That means the molecules are moving in a random direction. It is not moving in a fixed direction. There is an energy associated with these molecules. And these molecules are not capable of rotating the paddle wheel because these move in random direction. It doesn't move in a fixed direction. But at the bottom, these all the water will move in a uh, fixed direction. So that is why it is able to rotate the paddle wheel. So macroscopic energy, it is associated with the molecules. It has got a fixed direction. It is an organized form of energy. You can say that macroscopic forms of energy is an organized form of energy. Microscopic energy is the energy associated with the molecules which moves in random direction. That means uh, you cannot extract energy from this microscopic of energy or the internal energy easily, but it's easy to extract energy from the macroscopic kinetic energy. That means the potential energy or the kinetic energy of the system, you can easily extract energy.